Good evening, sir.
Good evening.
Good evening,
sir.
children. Good evening.
Yes, sir.
Good evening.
Good
sir.
evening, sir.
Good evening, sir.
Good evening. Yes, today's thing is still we are continuing with that problem solving in straight line motion with a constant acceleration. All right. So the sixth lesson, kinematics of particles 6, problems and motion in a straight line with a constant acceleration. Just a small area of kinematics I chose. I told you already. In the simplest of the ideas or in the simple looking ideas, there'll be very good problems set. And as I told you, we need to get into that habit of doing problems. All right. We have left few problems yesterday. Those problems and more problems we'll try today. All right.
Yes, sir.
Come on. A point mass starts moving in a straight line with a constant acceleration a. At time t1, after the beginning of motion, the acceleration changes sign, remaining the same in magnitude. Determine the time t from the beginning of motion in which the point mass returns to the initial position. So as usual, we'll picture the question, right? As I told you, whether you picture it on the paper to begin with, and whether you picture it in mind in the exams. In the exams, to save time, we don't write many things, and there won't be enough space, especially in the entrance exam. There'll be few small space for rough work. But anyway, since we are discussing it, let us picture it. A point mass starts moving in a straight line with a constant acceleration a. Like this. You can say this is my origin O. The acceleration is a. All right. After some time, how much time? At a time t1 from the beginning of motion. That means until t1, the body goes on accelerating. What do you say? Somewhere here, let us think the time until here is t1. And starts moving. Probably the initial velocity is 0. So after a time t1, what will happen to the body? It gets a velocity at1. How do you know that? From v equals u plus at. U is 0, acceleration is a time t1. So until here, the velocity was going on increasing. And at this point of time, the acceleration reverses sign. This was acceleration like this. That means speed is going on increasing. But now the acceleration reverses the sign here. Acceleration reversing the sign doesn't mean the body is coming back. The body's speed is decreasing.
Yes.
Isn't it so? Huh?
Yes.
So at1
Yes,
to somewhere the speed becomes 0. But this acceleration is still there. So now it really increases its speed and keeps coming here. So from beginning of motion here to go there, come back, he's asking you to find out the time. And definitely remember, the answer should be in terms of a and t1. Because a is given. Probably a may come, a may not come. So if you look at it in a pure mathematical way, I can do this. I'll start my time from here. It goes there and comes back. What is the displacement, children? If it comes back to the same point, what's the displacement?
0.
Equals 0 equals, tell me. This is here, the velocity is at1. This will become the initial velocity for the next motion, right? From here, if I start, I'm doing a little mathematical. We can divide that into two parts and do later. but just listen to me for some time. I want to use this idea that when the body is coming back to the same point, the displacement is 0. This 0, what should I do? Look, listen, children. If AT1 is the initial velocity for this motion, and deceleration is A, time from here to here will be how much? See, I've taken my origin of coordinates here, but now, right now, I'm measuring time from here. Time from here to go like this. I want you to listen to me carefully, otherwise you'll miss this idea. To go there and to come back like this, let me say the time is T2. I put it in blue. Do you follow this? From here, it goes there, comes back and goes here. That time is T2, I thought.
Yes,
Right?
sir.
Now, but my displacement is taken from here. So I'll write it. First of all, I'll write this one. From here, if I write U is how much, children, here? A
T1.
T1 into T2 is the time, minus, why? It is deceleration. All right?
Yes, sir.
Half A T2 square. But look, this is this initial displacement here, right? I'll call it S0. So S0 plus, I'll write like this. And how much is S0, children? Hari Vignesh. How much is S0? Half A
T1 square by
T1 square. Isn't it so? U is 0. So plus A T1 T2 minus half A T2 square is the equation. Deliberately, I put it in a little mathematical way. We can as well try slightly more physical way, which is easily understood, but I want you to get into this analytical approach. Tell me, children, can I write like this or not? I'll wait for your response. I can write like this? Huh?
Yes, sir.
Now, what you need to solve for? You need to solve for
T.
once you get T2, the answer will be what? T1 plus T2, because he's asking the time from here. So this is one analytical way of getting the answer. Bhuvana, do you follow this?
Sir, why did we add S0, sir?
See, my starting position is, my origin of measuring displacement is at 0. It could be S if you want. I can write S minus S0 also, I could write. Tell me.
Yes, sir.
This, actually, though it is coming back, I took minus A only because in the beginning, acceleration is backward. So I need not even know whether the body is coming back or not. Try to understand, because I made it 0. So let us simplify this question. Okay, that's one thing. Another way I'll tell you, just that will be easy for you to catch. After that, you can come back and talk to me about this. Look, the first time is already given as T1. Until then, it is acceleration, right? Then from here it becomes deceleration. Look, it started from rest, children. To stop, will it take T1? Once again, T1, can I guess? Tell me.
Yes, sir.
Children, it started from rest, uniformly accelerating, gets a speed, whatever speed we have, like I told here. But that speed should become 0 in the same time because the same acceleration is reversing the sign.
Yes, sir. It will.
Yes, sir.
Isn't it so? Tell me, children.
Yes, sir.
Yes,
Huh?
sir.
Right.
Yes,
So
sir.
to go there, we've got time 2t1. Leave it aside. Now from here, it is coming back. From here, it is coming back.
2T1.
What do you say? So how much distance it already traveled? You know, half AT square plus half AT square, T1 square once again, I can say, isn't it so?
Yes, sir.
Even here, even though you're doing it in a physical way here, even for that, you require to think. Can I say this distance backwards it is traveling is AT1 square, children? Can I say like that or not? Look, S1 equals UT 0 plus half A.
81
81.
square.
And for S2, when I write, I've got the final velocity. I'll write S2 equals final velocity
Mine.
0 into some T2, let me say. T1 only we decided. Minus half minus A T1 square. You understand which equation I'm applying here? Vt minus half AT square I'm applying.
Yes, sir.
But A is minus. This minus is there in the formula. This minus is coming because of the deceleration.
Deceleration.
What do
Acceleration.
we get now? S equals once again half A
T1 square.
Sir, VT or UT, sir?
This is S equals UT plus half AT square formula. Here I applied S equals VT minus
VT minus half.
I've given you the
Okay,
formula
sir.
already.
Okay, sir.
Now the total distance will be how much, children? Half AT1 square plus half AT1 square. AT1 square back. Right?
Yes, sir.
It starts with 0 velocity. Travels this distance. And let us say it takes a time of some T2 here. So what is the equation can I write, children, here? AT1 square equals U equals 0 into T2 plus half A T2 square.
T2.
T2 is the time from here to here. Do you follow?
Yes.
Sir.
Distance covered is AT1 square. Initial velocity is 0. What do you say? So A getting cancelled. I'll get T2 as what? Root 2 T1. So my answer will be, tell me, 2 T1 plus root 2 T1. This is in terms of what is there. And solve T2 here and add it to this, you'll get the same thing. So this is method 1, method 2. Tell me. Here you need to complete it. I have no space and I don't want you to show how to solve a quadratic equation by now. Tell me, children, can I continue?
Yes, sir.
But you're free to ask questions, analyze it. Children. Yeah?
Yes, sir.
Tanishka? Aryan?
Yes, sir.
Aryan?
Yes, sir.
Sudesh? Are you coming to my class, Sudesh, every day? I don't know. He's not speaking.
Yes, sir. Yes, sir.
You're coming. Have you followed
Yes, sir.
the question?
Yes, sir.
Huh?
Yes, sir.
Sudesh, I'm asking Sudesh. Hari Vignesh, of course, you're coming. I've seen. Sudesh, from Maharashtra. That fellow is not speaking. Okay. And here Aditya, Tejas, are you all there? Okay, that's left to you. Come on. Now, any questions here, children? Shreyas, Anirudh. Yes, Shreya, any question? And meanwhile, did somebody solve here? Here, T1 is a constant, children. T2 is a variable here. Okay. So this ultimately becomes, look, A anyway goes. This will be T1's 0 equals T1 square. This is a constant, children, not its known value. 2T1 T2 minus T2 square you get. So this is a quadratic equation in T2. Yes, any question, children? Okay, I'll go for the next one. Can I go to the next question then? I am.
Yes.
Come on.
Sir.
Yes, Shivani. Shivani, you are about to say something?
No, sir. I
The sums are some very good sums. You go through them again. Of course, I'll give you for private use separately, but right now they're still there on the YouTube.
Yes, sir.
Just one.
Done, sir.
This is a good question again. At the initial moment, 3 points A, B, C are on a horizontal straight line at equal distance from one another. So immediately in our mind, we should draw the picture. Or here on the paper.
Sir, you went to another problem.
Yes, sir.
Yes, sir.
No,
Run a point ABC. This one, sir.
this one only, right?
Yes, sir.
This one.
This one, right?
Sir.
Yes, sir.
Yeah, that will. So now look at this. In the initial moment, 3 points A, B, C are on a horizontal straight line. Okay. And they're equal at equal distances from each other, right? A in the middle, B here, C. Point A begins to move vertically upward with a constant velocity V, and point C vertically downward with initial velocity, without any initial velocity, but at a constant acceleration A. You understood what it means? How should the point B move vertically? For all the 3 points to constantly be on a straight line, the points begin to move simultaneously. Bhuvana, tell me, do you follow this? A moves up with constant velocity. C comes down with a constant acceleration, no initial velocity. So B should move up or down vertically so that they are on the same straight line all the time. Have you followed the question?
Yes, sir.
So, right. Now, can I put, for example, this is in a time t, A is at some point like that, I'll think. it is traveling a distance of vt because constant velocity. Okay, and c is going with some acceleration.
Constant
At
X.
the same time t, it went half at square. So I should change the lens, of course. Just a minute. They should be on the same straight line. So just to plan it properly, if A was like that, for example, like this. You know why I did that? I will be having a distance of B here. Do you follow? I could have taken that little longer, little smaller, and the diagram could have come slightly differently. This is how much? Half at square. This is how much? Vt. How should point B move vertically? Nothing is told about B's initial velocity or its acceleration. So how should B move so that they are in the same straight line? Now C is here, children. A is here, and B is here. You can see that this length is slightly visible for you because that will make the things easy. Do you follow this? This is the initial distance.
Yes, sir.
This is, let me say, A. This is A. Do you follow the figure now, everybody?
Sir, B can even go upwards, no, sir?
Now, look, already I connected A and C, right?
Huh.
We should be coming down only in the way I put. If I put C little smaller,
Shorter.
A little longer, then I'll get a figure like this. B, I'll move up. Do you follow?
Yes, sir.
You don't know. Do you follow?
Yes, sir.
You can exactly draw the other figure if you want, children. Huh?
No, understood.
Come on. The figure has to be understood. A is moving up in a time t, it's at vt distance there. C has covered half at square. B's distance, we don't know. Our job is to calculate this distance, children, finally. If you calculate that distance, it will tell you the information about the velocity of it, acceleration of it, and the direction of motion. All the three will come once you calculate that. So it now reduces to what, children? It reduces to geometry. Am I correct?
Yes, sir.
So what shall we do?
Sir.
The area of similar triangles.
Similar triangles. Properties of similar triangles you should use and find out this distance. Okay, I'll say this is B dash. The original one was B.
Sir,
Yes, B dash. We should find out. Pavani, tell me.
sir, here small is the equal distance between the points, sir.
Pavani, what are you saying?
Sir is small a, sir. The equal distance between the points.
Yeah. No, this is, don't say A, this is some X you say. Because A I already used for this.
Actually, yes.
Call it X.
Okay.
Huh? So the total length is X, amma?
Yes, sir.
So,
Sir,
yes.
sir, can we assume that VT is equal to half AT square and try to prove that?
Emma?
That, sir, if here we drew it down, someone was saying we can draw it up also.
Yeah,
So can
in that case, I can say this is a little less here. This is a little more there. I can join like this. So B should be going
so
up.
can we make them equal instead and try to prove that?
We can't make it equal, no? If we make it equal, how do you get the information about B? B will be at rest only. Huh?
Yes, sir.
Isn't it? Right? So I should know that distance covered by B so that I can guess about its velocity and acceleration. Okay? So who will tell me in the smartest way possible for this? You know, the problem reduces to finding out this distance, children. Do you follow?
Yes, sir.
Huh? Aryan?
Yes, sir.
Yes,
Now
Yes,
how do I do? Just can you tell me any simpler way of doing it? Geometry, if you know, Bhuvana, you should tell.
By using similar triangles, we can do it.
Similar triangles I can use, or anything else extra extension. Can I do anything anywhere? Because this half 80 square, if I join like this, things may be easier. Huh? I don't know, that's left to you. Probably I can try like this. For me it appears. If I go down like this, life becomes easier, I'm thinking. Because this half 80 square, so we become VT plus half 80 square.
Yes.
This is already 2x.
Yes.
Huh? Tell me, children.
Yes, sir.
Yes, sir.
So, no, how you manipulate it actually is a student's own capacity, believe me. So, if this is half 80 square, look, I told you I wanted this distance. You can call it y if you want. That y I want. So, tell me. I've got a bigger triangle like this. And then you tell me. Are you trying it?
Yes, sir. Trying.
Or if I take like this also, I can try, but that's not, yeah, this is better for me. It looks better for me. So VT plus half 80 square. VT plus half 80 square, this distance, by 2x. This by this. This by this is equal to what?
Half 80 square minus y.
Half 80 square minus
Y by x.
Yes, half 80 square minus y
by x.
By x.
by x. Is it okay, children?
Yes, sir.
So I think it's happening like this with a single step.
Yes, sir.
Children.
Yes, sir.
Half 80 square minus y by x. All right. So 1x
Yes.
cancel, children. All right. So what do I get? Vt plus half 80 square is equal to 80 square minus
2y.
And what do I want, children? Y, isn't it so?
Yes, sir.
So what will be y? This 80 square coming this side becomes what? 80 minus half 80 square, right?
Yes.
Vt minus half 80 square equals how much, children? Minus 2y, isn't it? Y I wanted. So what do I get for y? Y equals minus v by 2 into t. Am I right? Plus half 80 square. Did you do everything correct? So I can say this two ways, or this can also be written as v by 2 into t. No. No need. That's enough.
That should be a by 2 above.
Or we can write it as t into
one more
80 minus
one more
v by
2 is there. I'm sorry. This is a by 2. Isn't it?
Yes.
So what will you say now? So what will you say now? This is the initial velocity. This is the acceleration. So what will I say now, children? It should go up with an acceleration of a by 2. Because I took y below, right?
Yes, sir.
Minus v by 2 means what? Y is actually, no, there's no minus v by, or if I write minus y, if I write v by 2 into t minus half 80 square. This is enough actually. Don't need no enough changing this. So from here, what will I say, children? Is Is everything correct here? The signs, did I go wrong anywhere? Yes, Shreya?
Sir, can't we say that v moves vertically up with an initial velocity of v by 2 and a deceleration of a by 2 from this equation only?
Minus v by 2 is going up, Amma. You say minus v by 2 down, you will say? No, what are you saying?
I'm saying that goes up with an initial velocity of v by 2 and deceleration of a by 2.
No, if we say it is going up with v by 2 velocity, this is not deceleration, plus only we wrote. Huh? First of all, tell me, are the equations, I mean, are the signs correct? Otherwise, we'll be getting the wrong thing there. Is it okay? I'll come back to that. Are all the signs correct? Tell me. Minus v by 2, yes. And plus half a by 2 t squared a half. So, y is taken down here. Which a by 2 is more of that we don't know. So that's the reason why we should say it should go up with initial velocity minus v by 2. We took this way positive, right? Huh? What do you say? Minus v by 2 down with an acceleration a by 2, or v by 2 up and deceleration a by 2. Which is correct? You tell me. Come on, decide it. This is plus vt we put. So minus v by 2 d down will be down only, right? Y minus y. Y is plus we wrote here. So I can write it as minus y equals v by 2t minus half. Yeah, that way I can write, isn't it? Minus y equals, I can write v by 2t minus half a by 2t square. I can say this way.
Yes, sir, that only I'm saying.
Your voice is breaking. Right, no problem. Now look at this. So this you can give the meaning, proper meaning. Isn't it?
Sir, C to C dash is positive or negative, sir? Half at square.
We can give it two meanings, but you need to check this is Vt plus V. We took V upwards like this, we took positive, right? Huh?
Yes, sir.
So
yes,
what
sir.
am I saying is going up with the deceleration of a by 2.
Okay, sir.
Whichever way. Come on. So we're only in second question. Can I continue?
Yes, sir.
Children, Sriya.
Yes, sir.
Right. Next. A helicopter takes off along the vertical with an acceleration a equals 3 meters per second square. That is second square. That is, and 0 initial velocity. In a certain time t1, the pilot switches off the engine. At the point of takeoff, the sound dies away in a time t2 equals 30 seconds. Determine the velocity v of the helicopter at the moment when its engine is switched off, assuming the velocity of sound is 320 meters per second. Sriya, do you remember this question?
Yes, sir.
Come on, others think about it. Look, a helicopter takes off from the ground, it seems, with an acceleration a equals 3 meters per second square. Don't ever worry that what about g? It's overcoming g and a net acceleration is produced upwards, 3 meters per second square, and 0 initial velocity. Okay. In a certain t1, in a certain time t1, the pilot switches off the engine. Somewhere here the helicopter is, for example, at t1 here, the engines are switched off. So first of all, what velocity will it have, children, when it goes up to this height, whatever height? Height will be how much, children, here? Half a t1 square, isn't it so? Tell me.
Yes, sir.
H
Yes,
equals
sir.
0 into t1
Yes, sir.
plus half a t1 square. Immediately respond, otherwise I won't be knowing whether you follow it. Here we put off the engine, so the sound is gone there, isn't it? Huh?
Yes, sir.
But the sound here takes some time to come to you. What he says is, at the point of takeoff, that means here, it took off from here. This is called point of takeoff. The sound dies away in 30 seconds from the beginning. You understand? It went sometime t1. Here the engines are switched off. All right. Now a person here will not hear sound after 30 seconds from the beginning. 30 seconds, yes. So the sound will come back by half at square distance to reach him, right? With a constant speed. That time is how much? Half a t1 square by c, because no acceleration for that. Constant speed for the velocity of sound. I call it c, for example. Huh?
Yes, sir.
Plus
Yes, sir.
the time it took to go up t1 is equal
T1.
to what he says is
T2.
so just one equation, but understanding is going to be important. Bhuvana,
Yes, sir.
do you really follow?
Yes,
And you
sir.
know very well, t1 we don't know, a is there, that is half a is how much? 3 into t1 is how much? We don't know, right? By c is 320 plus t1 I don't know, but t2 is how much? 30. So I'll get t1 from here. A quadratic equation comes once again, right? So
Solving, sir.
Sir,
velocity of sound is over. Find the velocity v of the helicopter. So v equals 0 plus a into t1. This will be your answer.
sir,
Yes.
Sir.
sir, I didn't understand why it is 1/2 square by c. Why it is by c?
Tell me, time equals distance by speed or not?
Yes, sir.
That's what I wrote. If the acceleration is there, we don't write it. S equals ut plus half at square, we write. If the speed of the sound is constant, if it has to travel half at t1 square time, how much? Half a t1 square distance. How much time should it take? Distance by speed. Alright. The helicopter took t1 to go there. Sound took half a t1 square by c to come here. That time he says is 30. That's the meaning of the question. Read the question, Shivani. You cannot
Yes, sir,
understand the
got it.
solution without the question side by. Huh? Shivani.
Yes, sir. Got it, sir.
Tell me, what did you get it? What did you get? What did you get? Can you tell me the meaning of the question?
Sir,
Just tell me
the helicopter is moving at a distance of half t1 square.
what at a distance? Moving a distance.
Yes, sir.
Mm.
By the time the sound of it reaches the person on the ground is c. No, speed, sorry.
You are mixing up speed, time, at to 2. Huh?
Sir,
Okay, tell me in Telugu. Either English or Telugu or Hindi, whatever. Emma, what's happening to you? I'm trying to do some good sums. I want to just push you a little harder. I told you already. What's bothering you? Aryan, do you follow this?
Sir, is it 80 meter per second?
Amma? Bhuna.
80 meter per second.
What is 80? V,
V, sir. V.
How much is T1?
No, sir, I took it in as variables only.
You put that 80 V by all that you put?
Yes, sir.
Mm-hmm.
Then V is equals to A into, I substituted the T1 value there
Mm-hmm.
in variables only. Then I substituted the values.
Achha, T1 equals V by A you put here. Huh?
Huh.
No problem. V is 80 you got. Probably. I'm not very sure. Just let others also.
Yes, sir. Sir, I got the same answer. T1 is 80 by 3 seconds and V is
Okay.
80 meter per
80
second.
by 3. Yeah, this is correct. Yeah, now this is 80. Now, others tell me now. I want you to follow the question, please. The setting of the problem, the first most difficult part of physics problems is to set up is the main problem. To set up is the main problem. Do you follow? This is what you mean by setting up. Here we set up the problem like this. But this is manipulation. The second part is the manipulation. The manipulation, if you do fast, I can help you how to set the problems. Pavani, tell me,
Yes,
Pavani,
sir.
do you really follow the question?
Yes, sir.
Really, can you explain me the physical situation there? Tejas, are you coming
Yes,
to
sir.
classes actually? Tejas, when I'm calling you on the Zoom, you're not responding. I don't know whether you're coming or not. Yes, Pavani, tell me, Amma. Quick. Make it fast. I have to go for the next question.
Yes, sir. Sir, it is given that a helicopter is moving vertically upwards.
But
Its
remember,
acceleration.
this has got an acceleration upwards, 3 meters per second square. So first doubt people will get here, where is G okay here? Isn't it? Where is G? The helicopter has overcome the gravity and producing an acceleration 3 meters per second square upwards. Net acceleration, that is. Do you follow? Pavani, when I speak to you, speak.
Yes, sir. Yes, sir.
And actually, you should ask, sir, how we can go with 3 meters per second square? Is it not 10 down like that? You should get it out, not me. Then?
Its acceleration is 3
What I
meters
was
per
trying
second.
to tell you was, don't put G here because he already mentioned that it has got an acceleration of 3 meters per second square, once for all. Then quick, I have to go for the next question.
Sir, it is starting from rest, sir.
Yeah.
So initial velocity will be 0.
Agreed.
And
Then?
after a certain time, that is T1, the pilot will switch off the engine.
What is the meaning of switching off the engine, children? Why should you switch off the engine there? Because the question says the sound should die away for the observer on the ground, right? So once the engine is switched off, sound is no more coming from the helicopter, right? But the sound which already emitted will take some time to reach the ground observer. So all this physical drama one should understand. So this is correct, and tell me, I'm going to the next question. This is the answer, final answer. Children.
Yes, sir.
Okay, I'll go for the next question. Pavan, you have not mentioned anything. I was and of course interfering in the middle, but you did not complete your discussion.
So, sir, when to a person who is standing on the ground, like when the helicopter takes off, sir, the sound, he will be able to hear it only till 30 seconds.
Yes, that's correct. That means that helicopter goes there, the sound comes back. All that time he says is
30 seconds.
30 seconds. That is the key in the problem. So if you followed that, our job is done. I'll go for the next question. Yes, Pavani, read the question. You only.
Yes, sir.
Uh,
A car is traveling on a straight road at a speed of 72 kilometers per hour. The driver suddenly sees the traffic light turn red and he applies brakes. The brakes cause a uniform retardation of 5 meters per second per second. The car travels 45 meters before coming to rest. Find the reaction time.
what is reaction time? Do you know?
Sir,
Look,
is it the time he applies brakes?
time he applies brakes means what is the meaning of that, child? Look, old people have got less reaction time. People who took alcohol will have less reaction time. Hmm? Young people like you will have reaction time to be very small, for example. Hmm? What is, see this going with 72 kilometer per hour? That is how much? 72 into 5 by 18. How many meters per second? 20 meters per second. When you want to convert kilometer per hour into 5 by 18, you do anyway, right? Huh?
So will it be the time in which he sees it and then stops
Yeah.
presses
No,
the
he,
brake?
he saw the red light. You should immediately apply the brake.
After
But look,
yeah,
there's
yes,
a
sir.
time gap, no? Like you apply, you see the red light and apply the brakes. But before
That
speed
will be the
starts decreasing, the
reaction.
car will travel some distance with 72 only.
Yes,
Do you follow this?
Yes, sir.
sir, followed.
Before the velocity starts decreasing, the car would cover some distance with what? 72 only. That is how much?
72. Yes.
20 meters per
20
second.
meters per
Second.
second.
So this distance, for example, whatever you will calculate, that divided by this 20 will be your reaction time. You follow?
Yes, sir.
So tell me, how do you calculate this? The car travels 45 meters before coming to rest. Come on. So this initial velocity is 20 here because it moved this distance with 20 only. But finally it came to rest somewhere. So what should I do? Children. So if I calculate the distance there, how much will I get, children, here? For example, now it's a question of simple calculation. I already set it for you. If I give the answer, that will be not a good idea. I'll give anyway finally, but have you all understood what is the meaning of this whole thing? You apply the brakes, but immediately you see and apply. There's a gap, isn't it? Huh?
Yes, sir.
Yes, sir.
There's a gap. So the car's velocity actually starts decreasing after you travel some distance with this 20 only. So I told you what is reaction time. This distance S1 by 20. So how do I get my S1? Car travels 45 meters before coming to rest. Here, this distance shall we calculate? The acceleration, all that we don't know. Acceleration is there, no? Sorry, it should be
So
there.
minus 5 meters per second.
This is there already, yeah. So what shall I do?
Sir, is 45 meters a distance from when he sees the signal or after he applies the brake, sir?
From here. From here.
So the distance between when he applies the brakes and comes to rest will be 45 minus S1.
45 minus
S1.
S1. Tell me now. Come on. What shall
So
I do?
that distance, the acceleration will be 5, minus 5.
No, tell me, what should I do? I'm asking you now. What is the next step? What is the next step? Can I write something like this, for example? S equals, I don't
So
know.
can we write ut plus half at square and u taking it as 20?
20
Sir.
into, or can I
Yes,
do like
yes,
something?
10.
0 is there, deceleration is there, initial loss is there. Can I do that? 0 square minus 400
square.
is equal to minus 2 into 5 into
5.
S. Huh? So S here is how much? S2, let me say.
45 minus S1 square.
This is how much? 10, 40, yeah? Huh? Isn't it?
Yes, sir. Yes, sir.
So this total is 45. This is 40. Right? So the distance here is 5. So T reaction equals 5 by 20.
20. Yes.
Is it all right, children? Come on.
Yes, sir.
Yes,
This
sir.
is V equals 0. 0 square minus 20 square is equal to 2 into A minus, so minus I put here, 10 S2 equals 400. So S2 equals 40. Where is S2, children? This one. But he says the car travels 45 meters from here when you saw the red light. Huh? So the distance covered with constant speed is how much? 5. So 5 by 20 is the reaction time. So any time in future, remember reaction time is this. Is it all right?
Yes, sir.
So I should go to the next question then. I was prodding you. You need to somewhat, involve. Otherwise, the fun in the questions is gone, children. Try to understand. So I go on giving solution for good questions. You'll say, the sum is good, but finally, you will not do a sum later like that if you don't respond. Okay. Can I go to the next question? Children?
Yes, sir.
I will go.
Yes, sir.
Bhuwana?
Yes, sir. I follow it.
This is, of course, a simple question. Come on. A man runs at a speed of 4 meters per second to catch a bus. When he's 6 meters behind the rear door, the bus begins to move with with a retardation, so with a constant acceleration of 1.2 meters per second per second. After what time will he be able to catch the bus? After what time will he be able to catch? Will he be able to catch the bus if the initial distance between him, something went away, and the bus, I don't know, it went away, and the bus is 6 meters, let me say 10 meters. Right. This problem is for you. If somebody is willing to tell me how to start, I'll write it for you. Aryan?
Sir, here U is equal to 4 meters now, sir.
U equals 4 for whom?
For a man. And V6.
Runs at a constant speed, you can write if you want. So there are two things, bus and the person. A very practical example, don't you think? Huh?
Sir. Sir, we can use V square minus U square 2AS now, sir.
Don't tell me some equations like this. This is a bus. Yes,
sir.
The person is 6 meters behind it. Somewhere here you think door is there. Just don't bother about it too much. That's not very important. This is 6 meters.
6 meters.
He is coming with what speed?
4 meter
4
per
meter
4
per
meter per
second.
second.
4 meter per second.
Bus was actually at us. It stopped at a station probably, right?
Yes, sir. Yes, sir.
So he has to catch the bus. So he started with 4 meters per second. Its velocity is initially 0 for the bus, but it has an acceleration of 1.2 meters per second square.
second square.
So what should I do? Supposing,
Then at that time he
yeah,
catches the bus.
let us think.
Then the person will 40. He will cover a distance of 40%, and the bus will cover half 80 square.
Yeah, so
And then we
40
will
equals
use
6 plus half a t square. Is it okay? Look at this. From here to there, the person has come here to catch the bus. So how much distance he traveled? 4 into t. But the bus traveled half 80 square only, right? Because it is starting from rest. So half 80 square plus 6
Yes.
should be equal to 40. This whole distance is 40, children. Right? So this 40 should be equal to what? This initial distance 6 plus half 80 square. So this is 0.60 square. So you're getting a quadratic equation again, right? Tell me, 2t 3 plus 0.3 t square. The calculation part, be careful. Am I correct?
Yes, sir, it's correct.
So tell me how much is t? You know, x equals minus b plus or minus root b square minus 4ac by 2a is the quadratic formula if you forgot it. Come on, children. And similarly, what you do? The later equation becomes what, children? 4t becomes 4t equals 10 plus half a t square. So if you can solve for t, that should tell you something. So who will give me the answers quickly? You tell me.
Sir, what is root 2?
Root?
Root 2 I got, sir.
Root 2.
Yes, sir.
Root 2 t square 2 into 3.6.
Sir, I did in another method, sir.
Yogi Raghavendra, please don't do another method. There will be only one method for physics.
Okay, sir.
I'm asking you correct answer. Why do you say some other method without time? Some equation writing is not important. You need to understand this. There's
Okay,
no other
sir.
method. If at all there's a method, it's there, but you did not do that. Just look at this, do it carefully and tell me.
Sir, is it 4?
4? How can it be 4? 4, 16, no. Some, I don't remember exact value. If you tell me the value, I can recollect it. Come on, kids. Aryan, Bhuvana.
Yes, sir.
So Why are you not giving me the answers? Shreya Dhama, क्या हुआ? Do you remember, Shreya, I was doing quadratic equations for you in the beginning for this reason.
Yes, sir.
Mm.
So we did a similar type of question there.
Yeah. But there I stopped with, I set the numbers in such a way that you catch the bus 2 times. But here probably you'll get only 1 time, if I remember. And the second case, you may not even catch. Check it. Huh?
Sir, I'm not getting the exact number, sir.
Why exact number? Why should you get some points? You'll get time should be 1 second, 2 seconds. You mean to say why? No need. Some decimals you'll get. Why not?
8/3.
8/3 approximately. It looks okay for me. I have to check. I'm not very clear. I forgot the answer for this. 8/3 looks okay. Only one answer? Come on.
Both 4 or 8/3.
Balavardhan, yeah, I forgot. Balavardhan, Vamshi, I want you to respond, children.
I got it as 3 seconds and 3.66 seconds.
Balavardhan, tell me.
3 seconds and 3.66 seconds.
I'm not sure. I'm not sure. That one. I'm not sure. No. Come on, Sriya, Aryan, Sriyans, Anirudh. Come on, children. I told you, you need to get these answers fast. Only then I can do something. I cannot have a solution in front of me and keep giving you the answers, no? Huh? Look, you allow me to spend my time in setting up the thing. The calculation should be done fast. Otherwise, I should change the screen and then do all by myself that quadratic equation solving. And you'll be watching. What will you be doing if I keep doing calculations for quadratic equations and all that? Okay, I thought I would do today's. Actually, I had a lesser goal, but even then we couldn't reach that. How many sums are there? Let me see. 1, 2. Yeah, 2 more problems are there. Okay, I'll try to cover up these 2 sums tomorrow. But I would like to start something more. I'll define physical quantities in much more proper way tomorrow. But tell me the answer for this question tomorrow. All right, children? I'll be closing it right now.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Thank you very much. End the show.
Thank you, sir.
Thank you,
Stop
sir.
share. Thank you. And end the session.
Sir, I got it as 4.3.
4.3 Shivani. Huh? Shivani, is it
Yes,
your
sir. Yes, sir. Yes, sir.
4.3, it doesn't sound correct. Anyway, solve it today. Tell me the answer tomorrow.
I got
Right?
it 1.4.
Sir, and for the second part, I don't think he will catch the bus, sir.
Yes, the answer for the second part is correct. He won't be able to catch the bus. That's correct. But why? You tell me from the numbers.
So the discriminant is negative, so we'll
Yes.
Minus
real
24,
values.
the discriminant.
Imaginary roots.
That's correct. That's correct.
Yes.
Right? Good. But the first time you just calculate it properly. Huh?
Okay, sir.
Okay, sir.
All right. I'm
Okay,
ending the meeting.
sir.
Thank you.
Okay, sir.